locating our place in space, and 1.04 is physical attributes of the Earth's landscape. Okay, the objectives that I have for this lesson, define the terms of like axis, grid system, elevation, scale, talk about Pangaea, however, I've heard it say a bunch of different ways, absolute location and relative location, which we kind of went over last time, where we are in comparison to places in the world. Okay, so basically the question comes up in geography, where are we? Well, basically we're just like that television show that said before, we are the third rock from the sun. Maybe you've heard that. It was a television show quite a while ago, but you have the sun, which we all know is the center of the universe, and all of the different planets revolve around it. So we have Mercury, Venus, and then we have Earth. Then we have Mars, Jupiter, and the other planets that are in there. The significant thing about Earth is it's far enough away from the sun that we don't burn up, and it is close enough to the sun that it keeps it warm enough that we can live here. Okay, so as we go and we narrow down more onto the Earth, we have first off what we call our cardinal directions. We have our north, okay, our south, our east, and west. And some things that people do make mistakes. We always do north and south first, and then east and west second. So we don't have an east-north place that we go to. It's northeast. Okay, what we've done also with the Earth as well is then we've started to break them up into what we call hemispheres. Now we have lines that go across. The line that goes diagonally across we call the equator and splits the Earth in half. And the one that goes vertically across, we call that the prime meridian. And using those two, we can break them up. So as you can see in this picture to the far left that my cursor is on right now, we call that the western hemisphere. And right below it, to the east of the prime meridian, that's called the eastern hemisphere. Over here on the other side, we have the northern hemisphere, which is up higher. And then south of the equator is the southern hemisphere. Okay, so let's do a little poll question real quick. So think about this in your head as you're watching this video. Which direction is incorrect? Is it A, northwest, B, east-north, C, east or southeast, or D, southwest? And the correct answer is east-north. As I talked about before, we always go north or south first, and then east or west. Okay, I did already talk about this just a little bit, but this is a little bit more to clarify. So we have the equator. The equator is an imaginary line that divides the Earth in half and creates the northern and the southern hemisphere. Okay, we have the prime meridian, which is over here, that splits the Earth vertically and creates the western and eastern hemispheres. And then you have also what we call lines of latitude and longitude. And so what we've done, if you look at this picture at the very bottom where my cursor is, we've basically made a grid system. You may have become familiar with these in math. They like the X and Y coordinates. That's exactly what we do here, and this is how we get exact location. What you do is you take from the very middle the equator and prime meridian, so you have that little center area, and then you either first go north or south, and then you go east or west. And that's why we always go, when we're talking about our directions, we go, northeast or northwest or southeast or southwest. It's because we always start off going up or down and then across. Okay, I have a little video that I'm going to play for you that really kind of helps explain it. It's a little animated video, and it kind of gets in stuff where we talk about different solaces, that kind of stuff. So I will play that now and then we'll discuss it. Oops, I apologize. Let's play this again.
You've seen the sunset, right? And if you get up early enough, maybe you've seen it rise too. But have you ever wondered, if the sun rises every day and sets every night, where does it go when we can't see it? Well, nowhere. It's actually us that goes somewhere, because we're on the Earth and our planet is always turning or spinning on its axis. Imagine a line passing through the center of the Earth that goes both through the North Pole and the South Pole. We call that invisible line the axis. Earth spins around on this axis like a top. This spinning movement is called the Earth's rotation, and the Earth's rotation is what gives us day and night. Every day, all year. If you're on the side of the Earth that's facing away from the sun as the Earth is spinning, it's night. If you're on the side facing the sun, it's, you guessed it, day. Now, hold on tight, because the Earth is actually moving in more ways than one. At the same time that the Earth spins on its axis, it also orbits or revolves around the sun. This movement is called its revolution. One full orbit all the way around the sun is one revolution, and the Earth takes 365 days, or 1 year, to complete a revolution. So have you got all of this so far? The Earth is rotating on its axis, creating day and night, and at the same time, it's revolving all the way around the sun. Now here's the thing. As the Earth is both rotating and revolving, it's not sitting straight up and down. Its axis is actually tilted, just a little. It's not all that much, but this tilt causes one part of the Earth to lean towards the sun, while another part of it is leaning away. This means that different parts of our planet's surface gets different amounts of sunlight and heat. So, why am I telling you all of this? Well, as the Earth travels around the sun, it creates a pattern throughout the year. This pattern happens over and over again, and I'm sure you've noticed it. At certain times of the year, you see the northern hemisphere leans towards the sun, and the southern hemisphere leans away. And at other times, the southern hemisphere leans towards the sun, and the northern hemisphere leans away. That pattern, my friend, is what makes seasons. When the part of the world that you're living in is leaning towards the sun, it's warm and the days are long. Summer. When you're on the part that's leaning away from the sun, it's cold and the days are short. Winter. In between, it's spring or autumn. If the Earth weren't tilted, we would have the same season all year long. So, revolution, rotation, orbit. Is your head spinning? Let's do a demonstration to shed a little light on these concepts. Okay, you're gonna need a globe and a table lamp without a shade, plus a table to put them both on. Put the lamp in the center of the table and turn it on. Put the globe on one side of the table. Now hit the lights. The globe is Earth. Makes sense, right? The lamp at the center of the table is the sun at the center of the solar system. Now slowly spin the globe. As the Earth rotates, the sun lights up one side of the planet better than the other. It's day where the light is shining more brightly on the globe, and night where it's not. Now let's see what the Earth's revolution around the sun looks like. Give the globe a few spins with one hand while slowly pushing the globe in a circle around the sun, or the lamp with your other hand. So, do you notice how the Earth keeps rotating as it revolves around the sun? If this were the real sun and Earth, by the time you get back to where you started, the globe would have completed 365 rotations or days, and that's another year gone by. So, what does all this show us? It shows that what looks to us to be the motion of the sun in the sky is really caused by the motion of the Earth. So now you know, when you look up and see the sun setting or rising, it's not going around us. It's sitting pretty much at the center of the solar system, while we, and the 7 other planets, go around it. That sun, always gotta be the center of attention.
Alright. So, that may have been a little cheesy for you, but still had a lot of very good information. As she talked about, we do have what's called an axis. So, from the very top of the Earth. Now, the thing about the Earth is it's on a tilt, okay? 23.5 degrees. And that's actually very important because if it was straight up and down and it wasn't on that tilt, the sun would hit the equator the entire time, and it hits the equator the entire time and it'd burn the center of the Earth up. So we don't want that to happen. So it has that tilt on it, as you can kind of see on the screen right here. and it's tilted. And so basically when it's tilted away from the sun, it's more shining on, you have what's called our tropics, which is 23.5 degrees north and 23.5 degrees south. So you have the Tropic of Cancer and then the Tropic of Capricorn. And those are named after stars, the astronomers could see stars. So you have the sun that shines bright, and when it's shining directly on the 23.5 degrees, the Tropic of Cancer north, it is summer in the northern hemisphere as it goes around that way. Now the Earth will make its way around, and of course it's rotating, and it comes in. When it hits the other side, it's hitting the Tropic of Capricorn, which it's summer in the northern hemisphere, but winter for us. And then there's times where it hits the equator straight on, which we call an equinox. We have both March and September equinox, and that's when we have the same amount of daylight in the day and the night, and it's our spring and our fall, depending on what season we're going into. So there are some terms that we need to know as we're moving forward. One is rotation. Okay, rotation is basically the Earth that spins around. It's spinning on its axis, and it takes 24 hours caused by day and night. Okay, so that's what causes it, the day and night, as it's spinning around, and it takes that 24 hours. If it was like the moon and just stayed one place and it didn't rotate, you would have basically a dark side of the Earth and a side that's burning up because the sun's always hitting it. So that actually cools the Earth down as well as we go into night. Okay, you also have the tilt of the Earth, which I talked about, which is 23.5 degree angle. And that's what allows us to have our seasons. Our season, and as well as it rotates around the revolution around the Earth, which takes 365 and 1/4 day, giving us our seasons. Then we also have the axis that I did skip there, which is the imaginary poles that are on both sides there. So we have the North Pole, we have the South Pole, and we have that rotation and revolution around the sun, which creates our day and our days, and then we also have our seasons. Okay, so here's a question. We got 365 and 1/4 day, and that's why we have a leap year. Okay, so if you need to look up what leap year is, in February we have one more day every 4 years to kind of compensate for that 4th day. Okay, as we're also talking about the Earth, back a long time ago, we actually had a supercontinent called Pangaea. What that was is we had one large land mass, and over time we have continental plates, and we'll be talking about the continental plates. I'm sure you've heard about them in earth science or other things like that, but those move and they shift and they change, and that's why we've came where they are. Because of these continental plates, they cause a lot of movement, which also cause for natural disasters, as we call them. So we have a lot of earthquakes, volcanoes, all of that stuff. Even tsunamis are caused because of the shifting of the plates. We'll talk about that more as we move along. Okay, in 1.04, we have geological terms and ecosystems. From tectonic plates, erosion, we'll be talking about water cycle and all of those different things. So let's start out with a poll question real quick. Which of the following is not responsible for determining the climate or long-term weather conditions of a region? Would it be A, elevation, or high-low, how high a place is above sea level? That's what elevation is. B, lines of latitude, C, lines of longitude, or D, currents. Okay, so lines of latitude are how high it is, how far away it is from the equator. Lines of longitude is just how far away it is from the prime meridian, and then currents are oceans. And the correct answer is... Okay, lines of latitude or longitude are the only ones that do it. Elevation, how high above it is from sea level. So you think about the mountains in Utah. If it's the higher you are, the colder you are, right? Theoretically. So the higher you get, the colder it becomes. If you talk about lines of latitude, which go up and down. So the equator is really warm. That's why they call it the tropics. That really nice warm area. Doesn't really have seasons, but the higher you get up to like the different poles, the colder it is. And then ocean currents. Ocean currents are running where it pulls warm water from the equator and makes other areas really warm. We'll talk about that when we talk about Europe. How like the United Kingdom and Sweden and areas like that are a lot warmer, even though they're really high up latitude-wise, and that's because of the currents. Okay, some other things that we need to be aware of as we're talking about the Earth. We have the... excuse me real quick. We have the structure of the Earth. The structure of the Earth, the very center of it, we have a solid inner core. Then we have our molten core, and then we have our mantle, and then we have our crust. And we also see we have really hot spots that this molten core has kind of came and seeped to the surface, like areas like Yellowstone. Yellowstone's a big hot spot where it's basically a super volcano there, and that's why you see all the geysers and stuff like that. We have different spheres that we talk about. We have the lithosphere, which is our solid Earth, as you can see with my cursor. The hydrosphere is where the water is found on the Earth. Water is both under the Earth, it's in our oceans, and it's above us as well in the clouds. Then you also have the atmosphere, which is our gases and our air that we have to breathe, which is so important for us. And then you have the biosphere, which is all our living stuff on the Earth. And all of that makes up basically our Earth system of science. Okay, then we're going to go over our physical different continents and areas like that. I did talk about the plates, and we're going to get to those in a second. That's on our right. But we have basically, we've labeled these different areas as they moved out from Pangaea. So we have North America, South America, well, our 7 different continents: North America, South America, Europe, Asia, Africa, Australia, and Antarctica. And then we also have our different oceans, our Pacific, which right here, we'll have our Indian Ocean, our Atlantic Ocean, our Southern Ocean, which is down by Antarctica, and our Arctic Ocean. That's the one that most people miss, is the Southern Ocean. Okay, as we're talking about our rainfall, water cycle, that kind of stuff, of course we have precipitation, or we have water that's here on the ground. It evaporates into the sky, which creates condensation, and those clouds that you see. As it tries to go over things, it gets heavy, and that precipitation begins to fall, like I believe it is today. That goes on here. You also have runoff that comes into there. We have some that seep into the water, and we have into the ground, and it's called aquifer. So we basically have underground lakes and rivers. Particularly in Utah, we have quite a few. That's why you can create wells and everything like that. And then one of the big things is we're going to be talking about is the Great Lakes, the largest freshwater lakes in North America: Huron, Ontario, Michigan, Erie, and Superior. So let's have a poll question real quick. Which lakes are the largest freshwater lakes in North America? Would it be Lake Tahoe, Lake Powell, Great Lakes, or Great Salt Lake? Give you a second to think about that. And the correct answer is the Great Lakes that I talked about. If we go back just real quick, Lake Tahoe and Lake Powell are actually man-made lakes. The Great Salt Lake is not a freshwater lake. It's salty. It doesn't have an outlet. And then the Great Lakes are those. Okay, as we're also talking a little bit more about temperature and climate, as you can see here, this has where the equator would go through, this dialogue in the middle. The tropics, they only have basically 2 seasons. They have a wet season and a dry season. So their winter is basically their wet season. As you go farther up, you have what we call the mid-latitudes. And this is where you're going to find all of your seasons. So summer, autumn, winter, spring. But as you go farther north or south towards the poles, they only have 2 seasons, which is polar day and polar night. So it's super cold. It's basically like our winter the whole time. And then there's all kinds of different climates that are in there. You have tropical. Utah is actually what we call a steppe, which is more like the sagebrush, that kind of stuff. We're not a desert. Although a lot of people call us a desert, we get a lot more rain than deserts do. Deserts would be more like Phoenix, Arizona area, that kind of thing, and a lot of area of Africa. Then you have like humid continental, those ones. You don't need to be familiar with all of these, but just to kind of know that they're there, that's a thing. Okay, that leads us to the end. Now, I do not go over everything that is in our material, okay? There's a lot of stuff that's there, and that is what you do, okay?